ignite. And yan yung basis natin mamaya sa selection ng foam concentrate sa flash point. Then we discuss about flammable liquids. Ano ba itong mga flammable liquids? Hydrocarbons. Ito yan. You know, and basic hydrocarbons are basically the same as fossil fuels. At ang mga common hydrocarbons ay methane, ethane, you remember your chemistry, right? In your college, propane, butane, pentane, and hexane. These are hydrocarbons na kung saan makikita ito. I try to research, no? There are top 10 petroleum companies in the Philippines. Oh, see? So, pagka-graduate nyo, pwede kayo magtrabaho dito. Masterin nyo lang yung foam suppression. You can apply as one of their engineers here. Okay? Petron, Shell, Sea Oil Phoenix, Liquigas, Insular Jetty, and SL Harbor. So, ito yung mga top petroleum companies na mayroong mga hydrocarbons fuel storage tanks sa Pilipinas na gumagamit ng foam suppression. And also polar solvents is dapat liquid na to. Polar solvents dissolves other substance with polar protic molecular structure, no? Ay sa mga example nga ay acetic acid and methanol na kung saan ginagamit ito sa mga subsectors ng chemical industry tulad nito. Sa basic ang mga subsector ng basic chemicals, mga chemical products, yan, mga pharmaceutical, soap, detergent, paints, yan. Yung mga rubber products, paggawa ng mga tires, saka mga industrial products, saka retrading, yan, gumagamit sila dyan ng mga polar solvents. Sa mga plastic products, no, mga plastic products at mga tubings, ito yung mga kanilang produkto, ito gumagamit din sila ng mga polar solvents. And sa Pilipinas, they have what they call SPIK, samahan sa Pilipinas ng mga industriyang kimika. So ang kanilang mga asosasyon ay Philippine Association of Paint Manufacturers, Philippine Plastic Industry Association, Philippine Oleochemical Manufacturers Association, Progressive Association of Printing Ink Manufacturers, Association of Petrochemical Manufacturers of the Philippines. So yun, with this makikita nyo na yung idea ang magiging application, no, or field or magiging future job target nyo din as long as you learn and master design, selection, installation of foam suppression system. So sa mga sinabi ko kanina, dun kayo pwede and dun kayo welcome. Okay, now we also learn about types of foam. We have protein foam, protein foam, 𝗵𝗶𝐹, 𝗵𝗶𝐹𝑃, and yung pinaka-latest laging ginagamit ngayon ay 𝗨𝗏𝐹 because it is a combination of synthetic stabilizer foaming agents, you know, fluorochemicals and synthetic polymers designed to use for polar solvents. The chemical makeup of this foam prevents the chemical solvents from destroying them. So ito na yung today's modern foam. At nung nag-study at kinompare lahat ng mga types of foam concentrate, so far si 𝗨𝗏𝐹 ang pinaka beneficial in terms of property. Yan, sa left corner. Ito yung mga properties dapat in terms of property, knockdown, heat resistant, fuel tolerance, vapor suppression, and alcohol resistant. So excellent siya sa alcohol tolerance. So very much applicable from polar solvents and hydrocarbon at the same time. Then, this is a figure that shows na ang 𝗨𝗏𝐹 is really a good quality and recommended foam suppression kasi when it is applied to polar solvents, the solvent, kapag 𝗨𝗏𝐹 ang ginamit mo, i-destroy niya yung foam blanket mo. But yung 𝗨𝗏𝐹, it will resist. Okay, the foam blanket. Ibig sabihin, kung layman's term sana, makapal at matibay. Okay, kumpara dun sa ibang foam. Kaya karamihan ngayon, when they talk about foam concentrate, 𝗨𝗏𝐹 ang choice nila, especially sa mga polar, sa mga solvents and resins. So ano ba yung solvents and resins? I will talk about later. Magdi-design tayo ng isang tank farm mamaya ng solvents and resins. Okay. And ang foam is applicable into these different applications. Pwedeng gamitin sa oil and gas, chemical, fertilizer, power generation, marine, defense, aviation, and warehouse. So In the future, maybe when you work in these different industries, 101% you will encounter foam system. Okay? Especially kapag ang warehouse mo ay hazardous warehouse, no? Ibig sabihin may mga chemical liquids doon na ini-store. Hindi pwedeng tubig lang yan, tsaka sprinkler, you know? Yan ang misconception ng karamihan ngayon. Even if yung mga ibang professionals, you know, alam na nilang flammable liquid, they still put water sprinkler, which is wrong. Okay, now for the products, according to code, kailangan daw ang foam suppression ay laging UL listed. Nakita nyo last time, I think I have showed to you how an equipment being listed. Every 3 years ito, nagre-report ang company namin to UL staff ng result, no, ng aming halimbawa foam concentrate para maipakita namin yung quality ay still the same as being tested before. Otherwise, we will retest it again. Okay? So importante na UL listed. You always have to tell your client that they don't need to cut costs by getting a foam concentrate na ginawa lang sa backyard somewhere else in other countries. I have an experience dito mismo sa Pilipinas. They have tried to use that. In the end, na double expenses sila kasi hindi naman naging foamy. Okay, yung foam concentrate na yon. They ended up buying another one. Okay? So it's always be a UL listed products. Now, let's move on. Dalawa ang topic natin ng design ngayon, ano? First topic is we're going to design and select yung foam suppression equipment ng loading bay. You know, what is loading bay? Okay, I'll discuss what is loading bay. Before that, let me show you a video para magkaroon kayo ng better view. What is loading bay? Ito karamihan nakikita sa mga petrochemical industries. Yung pinakita ko kanina, na mayroong mga hydrocarbon hazards, no? Yung mga sila Petron, Shell, meron silang ganito. Okay? So let's watch for a while. Oh, wait. Sorry. I have to unshare because I need to share the sound. Okay? Wait lang, Hindi pala naka-share yung sound. Okay. Yan. Okay, so here's the video. Okay. So, nakita niyo doon, that's a loading and unloading bay. Okay, that's a loading and unloading bay. If you notice, there's a nozzle on top and meron ding mga foam monitor sa gilid. So bakit? Bakit ganun ang pagkaka-design? I will tell you later. Okay? Sabihin nyo lang kung mabilis ako, no? Anyway, we have 4 hours. So I'll take my time para mas maintindihan nyo. Sa pagdi-design ng foam suppression system, particularly ito sa loading bay, is NFPA 16 and 13 ang ginagamit. I hope you are familiar and aware of what is NFPA, National Fire Protection Association, no, ng US. So the loading and unloading of flammable combustible liquid is one of the most hazardous operations to be undertaken at any manufacturing or storage facility of hydrocarbons or polar solvents. Okay, lessen the risk to lives of property, a quality fixed foam fire. So sasabihin ko ano yung quality fixed foam fire na yan, protection. Or a dry chemical is often. Yung dry chemical, that's another topic. I can also discuss that to you in detail in our future technical webinar or mentorship. As long as magiging active kayo sa fire protection ng PSME Technical Division. Okay? And mandated in FPA 16 and 13. So if a foam sprinkler system is installed to cover a loading and unloading facility, it is to be designed in accordance to NFPA 16. Installation of foam water sprinkler and foam water spray system shall be performed with the spacing of the sprinkler heads in accordance with NFPA 13. So ano ibig sabihin yan? Yung nozzle sa taas, kapag may canopy man nawala, ang pag-compute ng foam requirement is based on NFPA 16. Pero kapag in-space mo na, yung mga nozzles na yan, ibig sabihin punta ka kay NFPA 13. Ano bang meron kay NFPA 13? Sa NFPA 13, may mga table doon that shows what type of hazard is it. Basically, kapag ganitong petrochemical high hazard na ito, in a certain high hazard, mayroong certain spacing doon na kailangang sundin. Okay? So, yan yung basis. Two basic methods to protect loading and unloading. Okay? Ito, number one, foam water sprinkler mounted on the canopy. Ano ibig sabihin ng canopy? Ito yung covering nung ano. Ito yung pinakita ko kanina sa covering sa unang-unang slides ko na merong parang bubong. Okay? So meron daw is foam water sprinkler doon o kaya open nozzle. And with the supplementary ground sweep directional nozzle. So ano yung directional nozzle? Kanina sa video example is they use foam monitor. Pwede rin gumamit ng nozzle mismo. So I'll show that in the schematic diagram later. They also need a foam monitor. Ang foam monitor naman to nakalagay doon sa perimeter. Position to discharge foam directly into the loading and unloading. Kasi in case of a small fire, hindi naman necessary kaagad na lumabas lahat ng foam galing doon sa nozzle. Pwede mo nang gamitin si foam monitor nozzle. Okay? And then, a truck loading is typically defined a low profile dike or curb. So meron siyang dike or curb sa Tagalog siguro parang maliit na perimeter wall, okay? Which surrounds the loading area that will contain a spill. So kapag may nag-spill, i-accommodate ng maliit na parang perimeter wall doon sa kung saan nakapark yung truck. And in many instances, tank trunks have aluminum storage tank. And to have a spill fire start underneath could cause the aluminum tank shell to weaken. The nozzles are designed to discharge foam underneath the truck to give a rapid knockdown of any fire. Normally, 2 nozzles are used per loading and unloading bay. I'll show that later, paano yung positioning. 1 nozzle should be located near the rear wheels of the tractor and the other located at the rear wheels of the trailer. Both nozzles should be directed to discharge under the trailer area. Kasi nga, pag merong spill fire, pag sinabing spill fire, yung sunog sa taas, bumaba at nasunog na sa baba. Okay, so to prevent that, merong nozzles sa baba. Directly nakafocus sa ilalim. Okay? Now, it is also very important to remember that in some cases, the roof or canopy above the loading area may not cover the complete hazard. The area of a truck and or trailer parked in the loading facility must also be considered as part of the fire area. So kaya nga meron tayong monitor, no? And monitor protection system should be designed to cover the complete surface area of the hazard and can be used to protect the canopy, pumps, meters, or other miscellaneous equipment associated with the operation of the loading facility. Kasi yung nozzle nasa taas lang. Pag nag-discharge directly going down, what about may sunog sa left and right or other area of the truck? So yun yung gamit ni monitor, foam monitor. Okay, kasi pwede yang ilipat ang focus o ilipat ang target, ng foam monitor. Okay. Here's the schematic of a loading and unloading bay. How does it operate? There is a fire. So yan na yung fire, halimbawa, the loading bay. Once fire is detected by the detection system, ang detection system dito, ang heat detector is especially designed against explosion. Kaya ang tawag dito ay intrinsically safe, IS, explosion proof dapat ang detector. So, well, that one, I leave it to you as a research, please. I cannot explain everything today. Okay? Ano ba ang intrinsically safe detectors? So, now, once na-detect na yan, magkakaroon na ng flow. It's either an open nozzle dito sa may canopy o kaya sprinkler head na nag-burst. Okay, but in this case, it's an open head, kaya nga may heat detector doon na nagbigay ng signal sa deluge valve. Eventually, there is a flow of foam here hanggang sa the pressure will be reduced. Yung water supply will increase kasi nag-umandar na yung pump. And it will push the water into the tank shell and the foam concentrate inside the tank. There is a bladder tank na ini-squeeze ng tubig. Then lalabas na kayo yung foam concentrate, then it will go to your foam proportioner. Ito yung tinatawag na foam proportioner. Remember my basic fundamental discussion before, siya yung nagbi-mix ng foam concentrate and water. And eventually, there is a continuous flow of solution in 10 minutes. Okay? Kailangan ma-suppress, ma-contain yung fire. And of course, habang kino-contain yung fire, automatic na din yan na si Fire Detection and Alarm System ng planta, na-contact na niya si Bureau of Fire Department para maging backup to suppress the fire. So ganyan mag-operate si loading and unloading. The question is, how can I size my bladder tank? How can I calculate and identify the number of my nozzles? Okay, so ayun yung nakikita niyo yung sa baba, may nozzle din sa baba direct to the front and on the wheel. Sinabi kanina sa code, okay? And merong foam monitor o kaya mobile monitor na merong may tinatawag ito na inductor para in case there's a small fire, instead na gumana lahat yung hanggang sa bladder tank, ito muna ang magkikil ng fire. At pag hindi na kaya talaga nito, then that's the time that, the whole system will function. Okay? Now, here's an example. Isa itong planta sa Batangas. Okay? Loading bay. So there are two monitors strategically placed on the corners ng loading bay. So ito yung itsura ng loading bay. Ang loading bay ay basically ganito. Ayan yung mga canopy niya. Okay? Here's inside the canopy. Now let's design for that. So this is the canopy and this is the foam monitor being placed at the perimeter. Ang given ay, ang type of fuel daw na nandun ay hydrocarbon na gasoline or diesel. Ang dimension ng bay ay 10 by 2 by 7 ang height. Okay, 10 by 2 by 7 ang height. And the requirement is to select and size up the foam suppression equipment. So they wanted to put 2 mobile foam monitors around the perimeter as explained in the code. Kailangan na merong foam monitor and foam sprinkler heads at the canopy and underneath near the tires. So to make the design very simple, better make a Excel sheet. Doon sa Excel sheet, ganito ang magiging itsura. So ito yung area of protected. Ano yung flammable liquid. Then I have 2 bays, right? It mentioned here. And the curb area is 40 kasi 10 by 2, right? Length width, 10 by 2 is 20, dalawa. So 40. Okay? So if I were to look at this chart, yan, ang mga color blue ay mga given, no? Yun yung given, yun yung mismong sa planta. Si application rate, kukunin natin kay NFPA 16. Papakita kasi inyo mamaya. And then, dito sa other chart is yung application rate, again, we will take from the NFPA 16. So, from this constant, ito naman yung mga constant na magbe-base tayo kay NFPA 11. So, sinasabi niya kapag ang gamit ko ay protein or fluoroprotein type of foam or ARFFF, kailangan ko ng protein kailangan ko ng 6.5. Pero kapag 𝐴𝑅FFF tsaka 𝐴FFF 4.1 ang aking application rate, ang ibig sabihin ng application rate ay liter per minute per square meter. And the discharge time is 15 minutes. Okay? As mentioned in FP11. So hydrocarbon. So ito yung aking mga guide, yung mga sinulatan ko. And ika-calculate natin itong mga to, itong foam solution rate, kung ilang unit ang foam, ito yung aking mobile foam, and ano yung size ng aking bladder tank. Same thing doon sa chart na isa mamaya. We can compute for this foam solution, and later on we can size for the foam bladder tank at yung size ng deluge valve at saka yung proportioner. Okay? So let's go. Yeah. Before that pala, sorry. Before we're going to move forward to the design, kailangan meron na tayong na-download or hawak-hawak nasa desktop na natin yung mga data sheets ng ating gagamitin. So tulad nito, ang gagamitin kong nozzle ay non-aspirating. Okay, na nozzle. Pag sinabing non-aspirating, I remember my discussion before, pag non-aspirating is directly flow papunta dun sa nozzle. Kapag aspirating kasi parang may opening pa here on the side para yung papasok yung hangin, you know, to give more aspiration at magkakaroon ng more foam solution. Okay, ito naman non-aspirating pero may foam na siya, pero yung foam bubbles niya compared sa aspirating is less, but still can be compliant. Okay, so gumamit ako ng aspirating, ito kanyang technical data. Makikita mo na kung ano ang flow at kung ano ang angle niya, no? Makikita mo na kaagad, may K factor, may discharge angle, mayroong gaano ko dapat i-space ito, at meron na rin siyang minimum pressure. So nandito na lahat. From our case sa Fartech, you can go to our website, you go to the products, i-click nyo lang yon, makikita nyo lahat ng mga to. It's free to download. Okay? Then I can also show the distance coverage of my angle. So pwede ako mamili. Anong angle ang gusto ko? 140 hanggang palaki ng palaki. Okay? So now I also have downloaded my foam monitor. So I use a watercam foam monitor with this technical data sheet. Right? Andito yung model. Importante dito si flow. Ito ang very important dito. Okay? Kailangan itong isang take note natin. Okay, and of course, I use this mobile foam with a flow of 225 liter per minute. Now, for my bladder tank, I use this data sheet, okay, with the range of, I use vertical bladder tank with the range ng capacity mula 200 hanggang 2,000. So nakahanda na, no, yung aking data sheet. So nakapark muna yan, nakapark. Now, what's the methodology? Number one, identify the fuel to be protected. So in this case, hydrocarbon. Number two, make sure that you already have available data sheet. So nagkaroon na tayo, pinakita ko kanina. Number three, the dimensions of the loading bay is 10 meter length and width 2 meter per bay. So there are 2 bays. So yun yung ating protected area, yung dalawang bay. The application rate to be used is 6.5 as sorry, not NFP16, NFP11, yung nandun sa chart natin. Now, okay, we'd like to calculate for the number of foam nozzles at considering ordinary hazard 2 classification, yung nasa NFP13. Kapag OH2, ang spacing daw ay 3 meter. Okay, so I will use that. So if I'm going to calculate my number of nozzles, i-divide ko lang. I have my length 10 and the space is 3. I have 3.33. Of course, whole number I use 4. Ang width ko is 4 and divided by 3, then 1.33, I will use 2. Laging even number. So, 4 by 2 sa isang bay ay 8 plus 2. Remember yung nasa ilalim? Plus 2 na underneath the tracks. Therefore, sa isang bay, kailangan ko ng ito na yun, yung kabuuan. Kailangan ko ng 10 pieces, you know, of nozzles. Okay? Now, ano yung required total foam solution for curb area? So, ang formula is you just multiply that application rate because what's the unit application rate? is the liter per minute per square meter of the protected area. So ang protected area ko dito ay yung 40, yung dalawang bay, right? So 6.5 multiplied by 40, I will have a total foam solution of 260 liter per minute. Yan daw yung kailangan kong foam solution na maprotektahan yung loading base ko. 260 liters per minute area na, pero hindi pa na, per minute pa lang yan. Mamaya, kailangan kong i-multiply ng duration para makuha ko yung total foam solution. So, ito yung nangyari. Okay? So, yun o, yun yung, as you can see, biniligan ko, yun yung dalawang nozzle sa underneath. And product by means of listing test or special testing, ito yung reference natin ng 6.5 liter per minute per square meter. Okay? Sa close na ito. Ngayon, dahil chemical plant siya, ito yung reference ko sa spacing ko, NFPA 13. Okay? Table 4.6.2. Yan yung reference. Okay? So, ayun, na-space ko na, nabilang ko na yung nozzles ko. Therefore, I would like to know my actual flow per nozzle. So, since I'm using 10 nozzles, I divide it by 10. Therefore, I have 26 liter per minute per nozzle. Calculated yan. And based sa data sheet, ginamit yung K-factor na 43 and a pressure of 2.1 bars. Therefore, by using this formula, K is equal to Q over square root of P, ito lagi ang formula ng K-factor. Okay? Makikita rin ito even sa lahat ng catalog ng sprinkler head and nozzles. I'm very interested to get the actual flow of selected foam nozzle. So, i-multiply ko lang siya ng square root of 2.1. Q is, i-multiply mo lang yun, cross multiplication. Okay? So, I will have an actual 63 liter per minute na nozzle, which is, okay kasi, ang required ko lang ay 26. And ang actual flow nung napili kong nozzle ay 63. Therefore, it's more than the required. So, it's safe to use. By the way, itong equation na to, it is the equation that calculates the flow and pressure. Okay, saan na yun? Flow and pressure of water discharged from sprinkler heads according to hydronics engineering. Ito, yung aking napiling nozzle with that K-factor 43. Okay. And ito na ngayon yung kanyang model. So balik lang ako kay data sheet. Ito yung aking K-factor. I use 140 degree with this spacing at this rate. So by using this nozzle, it means that it's safe for me na gamitin kasi it's over the requirement. So ang foam solution ko ngayon, with that 10 minutes, I use 10 minutes for this application, is 630 liter per minute. Okay? Sorry, 600 liters. Now, if I want to, should that be liter per minute? Liters only of foam solution. Ngayon, solution pa lang yun. Ibig sabihin, may tubig at saka foam concentrate. Remember yung unang discussion natin na ang foam solution, kung ginamit ko ay 3%, 97% ang tubig, 3% ang foam concentrate. Ngayon, interested ako, gaano karami ang aking foam concentrate? So, 3% yung pinili ko, kaya i-multiply ko lang siya ng 0.03 with that certain duration. So, I will have 189 liters. So, with that 189 liters, ito yung reference ng duration, okay, sa NFPA 16. Okay, NFPA 16. With that, then I'll go to my data sheet. 189. Wala namang 189 in my equipment. Ang pinakamaliit ay 200. Therefore, I will choose this because it's also more than the requirement. So it's safe for me to use. I will use 200 liters of foam bladder tank. And with a proportional of 80. Paano ba nakuha yung proportional? Ito yung nagmi-mix. So, balik ako sa data, performance data, ang basis ko ay yung foam solution ko na 630. Based ako dun sa nominal flow range. Yeah? So, 630 and ito 200 to 32. So, pwede kong gamitin si 80. Okay? 80 na foam proportioner. I think it's 80 na foam proportioner. Actually, I can also use 75 to 100 C50, right? But meron kasing sinasabi na the lesser is your diameter, the bigger is the friction loss. So I opted to use the next higher size. Okay. So I have already sized my foam bladder tank based on yung canopy lang. Okay? Na-design ko na. Ito yung foam bladder tank na gagamitin ko. Ito yung proportional ko. Yan naman yung nozzle na ginamit ko, K factor 43, and that's it. Pero hindi nagtatapos doon. Meron pa kasi akong yung kailangan ko raw magkaroon ng mobile ng monitor o kaya mobile unit around the perimeter of my loading bay. Bakit? Kasi pag small fire, okay, kailangan ito muna ang gamitin. Okay, small spill fire. So how can I choose? Application rate times protected area uli. So remember, kanina meron doon sa ating table, ang application rate ng ganito sa monitor, sa mobile unit is 4.1. So I will multiply by the area. So meron akong 164 na liter per minute na requirement calculated. Okay, but my portable inductor capacity is 225, which is more than the required. So I can use that. Okay, ito yung reference. Ito yung reference ng minimum application rates and discharge times for non-dike spill fire. Kaya ako pinili si 4.1 because of this clause 5.8.1.2 kasi non-dike. Non-dike means pag sinabing dike kasi ito yung mga perimeter wall na talagang mataas na. Ito kasi napakababa lang na kung saan ay it will just contain yung spill from the tanker, no? Now, with this reference, I can also use yung kanyang duration na 15 minutes. Okay, and therefore ang foam solution ko na kailangan ko daw ay 225 times 15, which is 3375 liters of foam solution. Foam solution ito, may tubig at foam concentrate. Bula, in other words, pag naglaba kayo, ito yung bula. Okay, ito yung volume ng bula. Pero interesado ako sa ilang foam concentrate ba. Therefore, i-multiply ko na naman ng 3%. But at this case, for mobile unit or yung perimeter, I have to add 10% due to losses. Laging mag-add ako dyan sa design. So, I multiply by 1.1. Therefore, the actual kailangan daw ng foam solution ko sa aking monitor ay 101.375 liters. And if I use 200 liters, laging sabing dalawa, right? Which is capacity ko doon, kanina, kung babalikan natin, if I will come back to that catalog, yan, I use 225 which is higher. Ito na lang kasi yung aking available equipment, so that one I will use. Okay? If you have available equipment that is lower than that, is also good. But in my case, in this design, I use that, yung 225 na yun. So, laging dalawa daw. Remember, merong clause kanina na nakasabi, laging dalawa. Magkabilaan. Yun yung requirement itong design na to. Laging dalawa means I will use a foam, portable foam monitor with 200 or 225 liters, and my data here, this one should be 500. Sorry, this one should be 500 liter, not 400. And my summary then is, for this loading bay, kailangan ko ng 10 nozzles na ang aking deluge valve ay 80. Bakit 80 yung deluge valve ko? Kasi yung na-size ko kanina, remember, balik tayo dun, no? Yung na-size ko na proportioner is 80. Therefore, kasi pagkalabas ng foam bladder, ang direct na sa deluge valve. So, kapag ganon, automatic na yan, na anong size ng proportioner, yun na rin ang size ni deluge valve. So, I use 80. Then my bladder tank, which is I computed, is the 200 liter. Then my proportioner is 80, and my foam concentrate is 200 liter. So bakit 200? Kasi 200 ang laman nitong tangke. Okay? If the client asks me to put a reserve, mag plus 200 ako. Kasi nakalagay sa NFPA 11 na kapag in the event of fire, nagamit mo na yung 200, kailangan in 24 hours, i-replenish mo kaagad yung system mo into active mode. So for you to do that, kailangan may naka-standby ka lagi na another 200 foam concentrate. Okay? But sometimes client, sometimes due to, I don't know, financial reasons, ginagawa na lang next na lang ito. Okay? But still, they have to make sure na meron kaagad naka-standby na reserve. And to have that reserve, ang storage dapat niyan, hindi siya exposed sa sun. Otherwise, it will degrade its life. Kasi ang life ng foam concentrate inside the bladder tank is roughly 10 to 20 years. But if it is exposed to the environment, especially under the sun, that life will be lessened. Okay, so ito na ngayon yung BOQ, ito na ngayon yung pepresyohan ng vendor. Okay, if I am the designer. So ibigay mo na to kay procurement nyo, please get a quotation from all the vendors with this bill of quantity. Okay, so that's for our loading bay. Yan yung pag-design, pag-select. Napakadali, di ba? Mamaya, sa last part nito, bibigyan ko kayo ng just an idea. Kasi after nito, equipment pa lang kasi ito. Na-select mo yung equipment, meron ka na. Merong next dito, piping. Paano naman yung piping niya? Anong size ng mga piping? Ipapatakbo ko mula bladder tank hanggang doon sa mga nozzles. And then mula doon sa bladder tank din, papunta doon sa aking pump. So how can I calculate? So bibigyan ko lang kayo ng rough idea mamaya. The way how to do it is hydraulic calculation. Full hydraulic calculation. Sa panahon ngayon, meron ng software. Okay? It's good to have software now. Noon siguro, minamano-mano or gumagawa ng Excel. But this time, there's a lot of software that is available sa internet. Yung iba may bayad, yung iba libre. Okay? But for you as a student, maybe you can download those that is free para mapag-practicean ninyo. Okay? So, yun yung ating design ng loading bay for hydrocarbon. If you have any question, please reserve your question mamaya. If you want to chat na ngayon para hindi nyo makalimutan, i-chat nyo na para yung moderator natin, they can read afterward. Because we are now going to the next design exercise, which is yung pagdi-design naman ng solvent and resin tank farm. So kanina, hydrocarbon ang ating fuel. Remember? Ngayon naman, ang ating fuel ay polar solvents. So mas mababa ang flash point nito. Kumbaga, konting ignition lang nito, biglang kalat ang apoy. Very flammable, very hazardous. Okay? It's even more hazardous than hydrocarbon. Okay, now, before we go to that, let's watch this video again para magkaroon kayo ng idea what is a tank farm. Okay, let's watch. Sorry. gas. No? Ito naman nag-spill na yung fire. So how to suppress that? So diyan papasok yung supplementary protection, that is the monitor. Pinuno niya yung nasa loob ng dike. Yung sinasabing dike wall. Okay. So you just saw a video how a fixed roof tank, ang tawag doon ay fixed roof tank kasi meron siyang foam chamber. Later I'll tell you what is foam chamber. Suppress fire. And kapag nag-spill yung fire, merong si monitor. So yun yung isa-select natin ngayon. Terminologies. This should be terminologies. Let's go first for terminologies again. Tulad ng ginawa natin kanina sa loading bay. What is fuel storage tank? Fuel storage tank, also called petrol tank or gas tank, is a safe container for flammable liquids. Okay? Fuel storage requirements are based on fuel type, usage, and whether the fuel is combustible or flammable as used by the fuel flash point. No? Okay, so it can also be a resin or solvent tank. What material is used? Yung material na ginagamit, gravity, having a gravity of 40 degree, API or heavier. Concrete tanks with a special lining may be used for other services provided the design is in accordance with sound engineering practice. Majority daw sa mga storage tank work under atmospheric pressure according to API 620, okay? And the maximum allowable pressure of storage is 15 PSI. Kapag nag-exceed, considered na yan na pressure vessel. Okay? Since storage lang, kailangan ganyan lang yung pressure niya sa loob. So, this is a fixed roof tank. Fixed roof kasi cone-shaped, sarado sa taas. Fixed roof tank is a type of storage tank used to store liquids consisting of a cone or dome-shaped roof that is permanently affixed to a cylindrical shell. So meron lang yung opening, may vent yan to the atmosphere. Okay? Newer storage tanks are typically fully welded and designed to be both liquid and vapor tight. Liquid and vapor tight. The roof, that's fixed roof tank. Ito naman, meron pang isa, yung floating roof. Ano ba yung floating roof? Ito. The floating roof naman floats on a liquid stored at atmospheric pressure. It is consequently rises and falls as the level of the liquid does inside the tank. So, may opening yan sa gilid, dun sa kanyang seal, sa rim seal. I'll show you later. Meron ding protection yan. Then floating roof tanks are generally used to store volatile liquids to minimize the loss of stored liquid product inside the tank due to evaporation. By eliminate the free space above the stored liquid. Kapag kasing merong void or space, nagkakaroon ng vapor. Yung liquid. Tendency, nag-evaporate yon, magbabawas yung liquid. So ito talagang yung roof lumilipat, dumidikit mismo doon sa liquid para sa ganun maiwasan yung space. Okay? Now, what kind of protection device is used for protection of fixed roof tank? So fixed roof tank is using top pouring system designed to apply foam gently. Kaya meron tayo dito yung sinasabi na foam chamber. Okay? It is applied gently through the tank wall onto the burning surface of the fuel. Gentle application is preferred to maximize the efficiency of the finished foam. So ito yung one of the example. Ayun yung fixed roof tank, and then ito yung kanyang foam generator. Ito naman yung mga water spray. The purpose of water spray is to cool yung tank shell so that in the event of fire, habang kinukumutan nitong foam, yung liquid sa loob, ay hindi magko-collapse, okay, yung tank shell. So that's the idea of that. Okay. Ngayon naman, what is foam pourer? So, itong foam pourer, it is a device through which foam is discharged gently on top of roof tanks, floating or fixed. It is generally fixed with foam maker with the help of orifice plates. It discharges foam in such a way that the foam slides down gently into the roof area. Later, I'll show you what is that. Okay, and what is rim seal? So sa isang floating roof tank kasi, merong tinatawag na rim seal. Ito yung gap in between the perimeter ng sa taas. Rim seal fire protection system is designed to detect and extinguish fire in the rim seal area of the floating roof tank at the incipient stage. The system is fully automated in operation and uses the latest state-of-the-art technology based on hollow metallic tube. Yung iba, gumagamit ng linear heat detection. There is a video for that. So this is an example of a floating roof tank. Okay, so the way it is being piped, kung yung foam, yung fixed roof tank ay nandun sa gilid ng foam chamber, ito nasa this is another way of installation, no? Nasa ilalim siya. Okay, ang lagi nating isipin yung flow or pressure, yung flow ng liquid going ng foam concentrate or ng foam solution going into the system should be higher, should be overcome the friction due to viscosity, which is, you can talk more about that in other detail. So ito yung video of a rim seal of a floating roof tank so that you can have an idea ano ba yung rim seal, paano nagkaroon ng fire at paano nasusuppress. Okay, look at this. So in this design, okay, meron siyang foam truck to pump the foam solution, solution, yes. Kasi yung truck meron ng tubig tsaka inductor yan. So solution na itong lumalabas sa nozzle na to sa rim seal. Then it will seal the rim, no? Allowing yung fire kasi doon nanggagaling to be extinguished. Hindi naman mag-extinguish doon na mismo kasi nakadikit lang yung seal doon sa surface of the liquid. Okay, so that's how the rim seal system operates. Now, so I have just explained to you what is fixed roof tank, how it is being protected, what is floating roof tank, how is it being protected. Now, let's try to go to the steps how to design foam suppression, no, of in this example, a fixed roof tank. So first you have to, again, tulad ng sinasabi ko kanina, what is the fuel being stored? Very important, no? Mamaya ay pakita ko sa inyo yung table na ginawa ko sa project na to. I really identified ano ba yung nandun sa loob ng mga tanking yan for me to understand what type of foam concentrate do I need to use. Okay? So, kailangan natin yung fuel stored and of course yung properties niya, particularly flash point, yeah? And the tank dimension. Then, from there, I can identify my foam concentrate for the hazard. Then, now I will identify the foam discharge. So, ano bang gagamitin ko sa tangke ko? Is it sprinkler, foam maker, foam chamber? So sa case ko, sa design na to, I use a foam chamber. So I will select for a foam chamber kasi fixed roof tank siya. Okay? Then before doing any calculation, again, sabi dito, it is best to identify and get the data sheet. Kaya alamin nyo muna kaagad yung data sheet, i-park nyo muna uli sa iyong desktop. You can go to our website and download all data sheets andun lahat. Okay, here are my data sheets. Halimbawa, ito yung mga na-download ko na data sheets. Oh. So all possible data sheets na gusto kong gamitin, kinuha ko na. Okay? At pinark ko na sa aking computer, including yung mga UL certificate nila. Very important ito, no, na kailangan may UL certified. Okay, so this is the given. Bakit 44.6? Bakit yan ang dimension ko? Okay, kasi by inspection dito sa tank farm na ito, ang daming tank farm, pero ang goal kasi natin is to calculate for the most demanding ng foam solution. Sa case na pinili ko, siya na yung pinakalayo, siya pa yung pinakamalaki. Okay? So ika-calculate ko siya. Once na na-calculate ko siya, it follows na kapag kaya kong isatisfy ito, lahat nitong maliliit at saka malalapit, kaya ko nang isatisfy ang kanilang requirement. Okay? So gayon yung aking basis of design. Ito nga yung dimension ng tanking yun. It has a diameter of 11.2 and a height of where's the height? 10.7. Okay? Yan yung height niya. It's a fixed roof tank. Now, what I did, yung sinasabi ko, I already made an Excel file. Dami nilang tangke. So what I did, I asked the client, can you give me what are the fuel stored in each tank? So binigyan naman niya sa akin. No? Si tank 1 daw, isopropyl alcohol. Tank 2, acetate. Yan. Tank 4, shell sol hanggang sa tank 17. Okay? And methanol siya. Okay? So, then I try to identify, is it an alcohol or is it hydrocarbon or is it an alcohol, polar solvent? So, from there kasi, for me to know if it is a hydrocarbon, I know what foam concentrate am I going to use. I can use AFFF. If alcohol, I better use the ARFFF as I explained kanina earlier, remember? I don't need to use AFFF for alcohol kasi i-break lang niya yung aking foam blanketing. Now, upon inspection, I use tank 17 na siyang pinakamalayo. These are my given. Okay? Okay, so yung flash point, pag nalaman ko na kasi kung anong alcohol, malalaman ko na yung flash point. Where did I get the flash point? Si Mr. Google. Okay, you can get from Google or you can ask the client. Meron silang data sheet. Okay, pero most likely sa client. Kung wala talaga, worst comes to worst, nag-google ako. And what type of foam concentrate? Isa ko na lang na ARFFF kasi so far, ito naman yung pinaka-effective. So I use that. And yung application rate ko, saan ko kinuha yung 0.17? I'll show you later. There's a table. And of course, yung diameter, inalam ko na, which is pinakita ko kanina, makakalculate ko na yung area, surface area, makakalculate ko rin yung foam solution, and with this time discharge na nakita ko na dun sa NFPA table, and yung kung malalaman ko na rin kung ilang foam chamber at yung duration na to, based on that duration na nandun sa table, malalaman ko na rin kung gaano karami ang aking foam concentrate. So ito yung ginawa kong chart for me to easily, calculate yung aking sa pagdi-design. Kapag meron ka kasing Excel, lagyan mo lang yung formula, kahit palit-palit ka na dito sa mga black color na yan, kagad-agad bibigyan ka na ng red color information. So on this case, ang pinakamalaki nga na foam solution ko ay itong tank 17 14,612 with a foam concentrate of 438. Okay? How did I get that? I'll show you later. So, by the way, primary protection pa lang yung kinalculate pa. This is the foam chamber, yung unang nandun. Ngayon, kailangan ko raw ng secondary as required in the NFPA. Anong ilalagay ko daw? It's either foam monitor or foam hose line. Yung ibig sabihin, remember dun sa video, may monitor ang ginamit nila. Meron din, pwede rin gumamit ng hose line, yung hose na pwedeng i-roll. Okay? At naka-standby lang yun. I-directly connect mo lang doon sa line ng foam solution in case of fire. Open mo lang yun, then i-extinguish mo na yung maliliit na fire around it, yung spill fire. So again, sa tank 17, ito yung na-calculate ko na foam solution niya. Okay? Which is same as I did sa unang chart kanina. I got the not same. There is another way to calculate kasi dito naman given na kaagad yung foam solution based sa isang closed NFPA. I'll show you later. And pati yung time discharge na nandun na rin sa NFPA. So I can calculate kaagad sa aking foam solution based on the duration. Pati na rin yung foam concentrate. Pati na rin kung ilang foam hotline. And kung anong size ng aking bladder. Okay, so okay, let's go. First procedure. Very simple ito, very straightforward. Mukha lang overwhelming, mahirap, pero napakadali. You know, very kayang-kaya ng isang first year or second year college na intindihin ito. The area of my surface is circle. So I use A is equal to pi over 4D squared, right? Ni-calculate ko na yung flow rate. Ibig sabihin, yung area times the application rate. The application rate, okay, makikita ko raw sa NFPA 11 in terms of GPM or liter per minute. Now, if I'm going to calculate for my total flow, dahil nandun na yung aking total foam solution flow rate, then, I mean, not total flow, total foam concentrate, I have to multiply it by the duration. Ang duration, according to NFPA 11 and 16 or 13, iba-iba ang kanilang time duration application, no? NFPA 16 usually sa warehousing. Ito. Si NFPA 30, yung how to handle a flammable liquid, depende sa anong liquid yung ina-handle. And si NFPA 13, meron naman siyang 20 minutes sa section niya na foam. Okay? But NFPA 11, siya yung muna yung reference ko ngayon. Okay? Otherwise, kapag wala doon sa NFPA, lagi kasi ang manufacturer ay i-consult natin. Kasi si manufacturer, sila na yung may direct testing sa laboratory ng kanilang products, ng kanilang foam concentrate. Okay? So better we inquire to them. Okay? To make sure. Now, yung primary protection natin is based on diameter and height. For this case, foam timbers, siya yung ating primary protection. So, if I were to determine the application rate and discharge, I will go to table 5.2.5.2.2. Okay, ito yung minimum discharge times in application rates for type 2 fixed foam discharge. So, on a fixed roof cone, okay, that is containing hydrocarbon. So, yun yung mga condition niya. It's a fixed roof cone na mayroong hydrocarbon. Okay, ngayon, kapag fuel mo ay hydrocarbon, that's why I categorize my Excel, remember? Ito ang aking gagamitin. And I should know the flash point ng fuel. And I can just use this or this or this. Anyway, pare-pareho naman sila. But magkakaiba lang nga lang sa discharge time. Kung ang gamitin ko ay crude petroleum, 55 minutes ko dapat consider yung discharge ng aking foam solution. Kung ang aking flash point dun sa hydrocarbon na pili ko ay 60 degrees lang, 37 until 60, 30 minutes lang ang aking discharge time. So sa pagpili ng discharge time at this condition na fixed roof tank tsaka hydrocarbon, dito sa table na ito pumunta. Okay? So then you can get this unit. Then however, kapag alcohol resistant naman, right, na fixed roof tank, itong table naman na itong gagamitin, 5.2.5.3.4. Kasi siyang magsasabi kung anong application rate. Halimbawa kami sa Fartech, sa design na ito, they ask me what is the application rate kasi this is an alcohol resistant. Then sabihin ko naman sa kliyente, sir, ano po yung klase ng ano nyo? ng liquid nyo? Yun. They will tell me. Then from there, I will tell them kung anong application rate ang pwede niyang gamitin. Pero laging 55 ang duration, ang discharge duration ng alcohol resistance based on this table. Okay? So, now I have determined kung hydrocarbon or polar solvent, then na-calculate, alam ko na application rate, pati discharge time. Now, next is, ilang discharge outlet, ilang foam chamber ang ilalagay ko. So, based on this table again, okay, alamin mo lang, from this nakalagay dito, for fixed roof tanks containing hydrocarbon, all flammable liquids requiring alcohol resistant. Alamin ko lang yung diameter ng tangke ko. From there, malalaman ko na kung 1, 2, hanggang 6. Take note of the bottom corner, +1 outlet for each additional 465 square meter. So yung tangke mo, palaki ng palaki, na mayroong additional 5,000 square feet ang area, magdagdag ka lang ng isa pang foam chamber. Okay? Then, you can calculate kung ilang foam chamber ka na. Now, I've just calculated my primary protection. Yung foam chamber ko, nalaman ko ano yung foam, pati foam concentrate solution, at pati kung ilang foam chamber. Ngayon naman, doon ako kay supplemental. Ibig sabihin, yung foam hose stream. Okay? Below my tank. For spill fires. How can I do that? How can I decide? I'll just go to this table, 5.9.2.2. Alamin ko na naman uli, what's the diameter of my tank? You can see from here, if I have up to 19.5 meter, I only use 1. Over 36, 3. So, kahit dumami pa ito, lumaki pa, hanggang 3 na yung pinakamaraming foam hose line niya or monitor around the tank. Kahit over 36 meter pa. Minsan may nagtanong sa akin yan, what if lumaki pa? Then I said, okay, look at these charts, 3 lang talaga. Ang mangyayari nga lang dyan, magde-decide ka lang ng GPM ng foam monitor mo if you wanted to upsize it. Okay, then, if I were to determine yung supplementary, ito yung sinasabi ko kaninang clause na kailangan nating tandaan. Sinasabi dito, the equipment for producing its foam stream shall have application rate of 189 liter per minute or 50 GPM. Ito yung nakita niyo sa Excel file ko kanina na i-phoenix ko na sa 50 GPM with the minimum number of hose stream shown in table 5.9.2. So yan yung laging basis. Additional foam producing materials shall be provided to allow operation of the hose stream equipment simultaneously with tank foam solution as specified in 5.9.2.4. So ito naman yung magiging duration niya. Okay? So alamin ko lang yung tank diameter and then malalaman kung gaano katagal yung i-multiply ko lang yung 50 times 10 kung hanggang 10.5 lang yung tangke. Okay? So that's my foam solution. Now, nadoble ito, no? Nadoble. Now, let's go to the actual calculation na. Okay? So, I just showed to you kung ano yung mga table na pupuntahan kapag nagsiselect. Let's go to the actual problem. So, ang tangke ko ay isopropyl methanol ang laman na mayroong flash point na 51.8 degree with a diameter of 44.6 and 40 feet yung kanyang height. Now, I will calculate for the primary protection, which is the foam chamber. First, I know the diameter, so I can calculate for the area, right? And the fuel is stored ay methanol, so punta okay 5.2.3.4. Tinanong ko si manufacturer, sabi ni manufacturer 0.17 per square feet ang iyong application rate based on fire test data ng manufacturer. So I use that. I get the area and I multiplied by the application rate. Then I have my flow, total flow of 265. Now I will calculate for the number of my foam chamber. Sabi kanina kay 5.2.5.2.1, I will again refer to the diameter of my tank. Therefore, since my tank is 44.6 na nakalagay sa table, dapat up to 80 isa lang. So I will use only one foam chamber. Okay? Then I'll go to my data sheet. Ang aking flow ay 265.68 BPM. Punta ako dito sa table lang. Ang ginamit ko ay CD inlet 100. Ayun, dito siya. Dahil ang kanyang flow ay 265. So nag-refer ako sa kanyang flow range. Okay, here's my flow range. I referred to my flow range here, okay, to 265 means within this area. Sorry. Flow range 190 to 750. Ayun, doon ako nag-refer sa GPM. So that's why I use this. Inlet pressure ko is 2.1 as mentioned here, somewhere there. And up to 7 bar. And ang flow range ko is 190 to 750. That's why I use this. I selected this in my foam chamber. O, di ba? Andali. As long as you calculated your foam solution, yun na yung basis ninyong foam chamber. So I have selected my foam chamber, isa na ganun ng size. Ngayon naman, foam bladder tank. Okay? I have to calculate for my foam bladder tank. But how long do I need to discharge yung foam solution na yon? Based on this table, 55 minutes. Okay? So 55 minutes. Then I have calculated that, I mean, 265 multiplied by 55, so I have 14,612. And kinompute ko na kaagad para sa foam concentrate, meaning i-multiply ko na ito ng 3%. Ayun o, 3%. Therefore, ang nakalculate ko ay 38.36 gallons na foam concentrate. Kasi yan na yung basis ko later on to size for my foam bladder tank. Okay? Punta muna tayo sa secondary bago tayo punta kay bladder tank. Sinabi doon na 50 GPM in clause 5.9.2.3. Nang kailangan ko ay isa. So, how long? Minimum number of host stream is 1. Nag-base ako rito. Yan, 1. Then, how long? So, ito naman. Ang aking tangke ay sinasabi doon na 44.6 dito, which is within this range. So, I use 20 minutes at using 3%. No? Now, yung aking secondary, if I'm going to calculate 50 times 20.30 gallons lang yung kailangan niya na foam concentrate. Therefore, yung foam concentrate ko kanina, okay, na, sana ba yan? I'll come back to that. For how much? 438, i-add ko lang ang kailangan ko rito. Therefore, I have 468 gallons. Now, if I'm going to select for my bladder tank, parang ginawa natin kanina kay loading bay, ang basis is yung aking foam solution. No? Ano bang foam solution ko rito? Ito na pala, 468 na identify ko na. So, based on this data sheet, ang 468 ko ay nagfo-fall under this 528 gallons, which is 2,000 liters. So I chose yung higher kasi 462 na yung next eh. So I chose the next higher to accommodate my requirement. Therefore, my foam bladder tank size is 528 gallons or 2,000 liters. And to choose for the foam proportioner, I use yung solution ko ng chamber, yung foam chamber plus yung hose line, pinag-add ko lang sila. Tapos, that will be my basis to go for the flow range, which is, it falls under here, yung 315. Then, I can use my foam proportioner na 80. And ang water requirement ko sa requirement na to, kunin ko lang yung total foam solution, i-multiply ko lang 0.97. Ito na yung sasabihin ko kay pump supplier. Ito yung gusto kong i-size mo na pump ko. So pwede siyang bigyan niya ako ng 500 GPM na pump. Okay? Now, if I go to the data sheets, ito na yung naging design ko. 528 na foam proportioner, 2,000 liters. Aking foam chamber ay ito yung kanyang data. Of course, whatever is the size of my foam proportioner, it will be the deluge valve, and my foam hose line, I will use a 50 GPM foam hose line. Okay, sa isang tank farm, it needs a fire alarm and detection system. Okay, it has to be a remote activation panel, and at the same time, merong provision of manual activation lagi. So that's another selection actually, but I will not touch that now. So ito na, na-design ko na yung requirement ko for a foam system sa aking storage tank farm, yung pinakita kong most demand na tank kanina. And that is the one that I'm going to ask for a quotation. Okay, so yeah, that's it. I have already selected my equipment, yung mga sizes, pati quantity. So next is what? Hydraulic. I'm not going to go through the detail, but I'll just give you an idea how the hydraulic calculations work. So sa hydraulic calculation kasi, i-check natin yung ating pipe sizes, no? If it satisfies with the water requirement, and of course kapag na size mo na yan, ni-run mo na yan, it will give you a result kung ilan din rin ang size nung yung pump, no? Water requirement ng pump. So in which dito naman sa pag-calculate natin dito sa tank farm, meron tayong water requirement for foam and water requirement for spray. Okay, which is makukuha naman natin kaagad doon sa calculation. Doon naman sa loading bay kanina, it's the same thing. Pero sa tank farm, dalawa ang pagkukuhanan mo. Sa foam system mo at saka yung spray, yung cooling nung tank. Hindi ko na pinakita dito kanina, but the way how to do it sa water spray is madali lang yon. You just get how many nozzle. Ibig sabihin, kunin mo yung diameter, divided by 3 ang spacing, malalaman mo kung ilan ang nozzle sa isang layer. It's always been 2 layers. And then from there, you can have the catalog. Meron dun yung flow nung nozzle, i-multiply mo lang how many number of nozzles, and then you can have a rough estimate of water demand. Okay? Now, but going back to this hydraulic calculation, ito yung software na ginagamit ko. Actually, I don't know if free pa ito sa internet. Ito kasi yung ginagamit ko even nung nasa Singapore pa ako. So, the way to input is, kailangan mo lang input yung data, including kung anong hazard, okay, and all the other detail like kung anong sizes, minimum and maximum sizes of your piping, and including yung maximum drop pressure. Itong mga to, itong data na to, nakabase kung anong hazard ang ginamit mo. For example, okay, this is my project back then in Indonesia. Okay, it's a paint factory. This paint factory, when we calculated for the finished good warehouse, so nag-base kami sa design density na 12.2 with a remote area na 270 square meter. And ito yung total water required na 20 sprinkler ang calculated because i-base ito sa ordinary hazard 2. Okay? And ito yung schematic niya. Now, if you input all this, by the way, yung sinasabing discharge density dito makikita kay NFPA 13. Dito sa figure na ito. Pag light hazard, ordinary hazard, okay, malalaman mo kung ano ang discharge density mo. Ano ang design density ng inyong system sa NFPA 13. So going back to that, ito ngayon yung input namin sa project. So it's a high hazard, and the design area is 140, tapos yung area of operation at saka yung maximum area per head, in-input namin dyan. And then when we run the software, it gives us this. So yung dinilagay namin design density na 12, na-maintain niya, no? Nang in-input namin. Ibig sabihin, tama yung aming pipe sizes doon sa aming na-input na minimum and maximum. Okay, and then dito kasi sa ano na to, sa software na to, you have to manually, okay? You have to manually i-input itong mga to. Halimbawa, anong length? North. Ganyan. Ganun yan. Length east. East is right, yeah. Length south. Length east. Ganun lagi ang ano pag-input. Merong part nitong software na to that you have to put all this east, west, south, yung direction niya, and siya na mismo mag-layout sa iyo ng ganito. So ito yung naging layout, 3D layout doon sa software ng aming calculation. Yan yung sa pipe sizes niya and sa flow and yun naman sa pressure. So sa software, mas madali kasi you just have to input ano yung hazard, ano yung maximum minimum sizes, ano yung protected area, and then ano yung ile-layout mo rin yung pipe sizes. Kapag merong nag-red dito, okay, sa density may nag-red or nag-zero, meaning your sizing is wrong. So you have to redo it. Change your sizing doon sa dito. Change yung sizing mo dito. Somewhere you have to change the sizing. So yun yung idea. I will not do an example of it now because it will take so much of our time. Maybe another time we can do it. Kuha tayo ng isang example using my software. Okay? So we just calculated and designed for a loading bay. Yeah, for a loading bay, we just selected an equipment for a tank farm. So dalawa yung nagawa natin ngayon, isang pang hydrocarbon, saka isang pang polar solvent. So always remember lang when you do selection sa mga foam suppression system, you should be guided by the NFPA standards. Okay? Don't worry, these slides, okay, will be given to the organizer. It will be given to you para meron kayong pagpraktisan, meron kayong gagamitin. I will send it as a PDF para meron kayong guide in your calculation. Okay? So pwede kayong mag-practice. Once na alam nyo ready na kayo, expert na kayo, i-email nyo ako kasi baka may mga projects so hindi ko na kailangang ipagawa sa India. Kayo na lang ang freelance freelance design. Yung mga nag-email pala sa akin last time, hindi ko muna kayo ni-replyan kasi gusto ko munang i-discuss ito sa inyo. Baka confident na kayo to do it and to be a freelance designer. Tapos marunong ka pa sa hydraulic calculation, I think you are suitable for a maging partner sa isang project, no? So, well, I guess that's all for our presentation for today. I do hope that we have learned something. Siguro kung may question, let's go to it and let's try natin kung masasagot. Otherwise, I'll answer it through an email kung ano yung dapat na sagot. So yun, thank you very much. Let's go back to our MC and moderator. Thank you.
So thank you so much, sir. So I'll just transfer po the floor to my co-host po, our Vice President of Internal Affairs, Mr. Joel E. Viernes.
By the way, may I know kung sino sa inyo ang pumasa sa board exam last past exam ng PRC? Pakibigay yung names nyo sa ating organizer. Kung anong chapter kayo, especially those who are from Cordillera, La Union, and Pangasinan, because we are planning to conduct a event for you. So kung sino yung pumasa, i-chat nyo na lang.
Excuse me, Joel. I think you are muted.